Now I will discuss general integration, formulas, and U substitution. So, our learning objective in this discussion is to learn and to understand the general integration, formulas, and U substitution, and to master the techniques of U substitution. So, the principle and concept of this lesson is the general integration formulas. We need to know the formulas of this lesson. So, the number one formula is the integral of u raised to n du is equals to u raised to n plus 1 over n plus 1 plus c. So, n is not equal to negative 1. So, that n will not be equal to negative 1. So, the number 2, the integral of du over u is equals to ln u plus c. The number 3, the integral of e raised to u du is equals to e raised to u plus c. And number 4, the integral of a raised to u du is equals to a raised to u all over ln a plus c. So, I have 2 examples in this lesson. So, example number 1, the integral of x plus 1 dx all over square root of x squared plus 2x minus 4. So first, let's find the u and the du of this problem. So our u, let u, our u is this, the x squared plus 2x minus 4. So u is equals to x squared plus 2x minus 4. And our du is the derivative of our u is 2x plus 2 dx, or it will become 2 times x plus 1 dx. So now we can solve the problem because we have u and du. So this will become, so we will find the formula. So the formula that we will use is the du over u, because the du in this problem is in the numerator. This is the u, and the du is in the numerator we have the du, and in the denominator we have the u. So we will use this formula, the du over u. So it is equals to 1/2 integral of d over u. So it is equals to 1/2 the integral of u negative 1/2 du. We will put the denominator to numerator, so it will become negative. So this will become 1/2 times u raised to 1/2 all over 1/2. This become 1/2 because negative 1/2 plus 1 is equals to 1/2. So that's why this is 1/2. So plus c. So it will become this will be cancelled out, so it will become u raised to 1/2 plus c. So now we will put the value of u, so it will become x squared plus 2x minus 4 raised to 1/2 plus c, or it will become square root of x squared plus 2x minus 4 plus c. Erase space. Plus c. So both answers are correct. So our example number 2 is the integral of dx all over x ln x. So first we will find the u. So let u is equals to, our u is this, our u is ln x. So ln x and our du is equals to dx, or this is our du. So dx over x. So our formula is du over u, because this is our du, and the u is in the denominator. So we will use du over u. So it will become ln of u plus c. So we will put the value of u, so it will become ln of x plus c, or ln of x plus c. So this is our final answer. Technique of integration by parts. So the learning objective of our lesson is to learn and understand the integration by parts and to master the techniques of integration by parts. So now I will discuss the principle and concept. So first we will recall the formula for integration by parts. So we will recall the formula d times uv is equals to u dv plus v du. And it will become the integral of u dv is equals to the integral of d times uv minus the integral of v du. So this will become the integral of u dv is equals to uv minus the integral of v du. So this is our final formula. So now I will give 2 examples for this lesson. So the problem number 1 is the integral of ln x dx. So first, let's find the u of this problem. So our u is ln x and our du is dx over x. So now we will find the dv of this problem. So the dv of this problem is dx. This is the dv, and this is the u of the problem. So the v is equals to x. So now we will solve this problem using this formula. So uv minus the integral of v du is equals to the u is ln x. So this will become x ln x minus the integral of v. So minus the integral of v is x. So the integral of v is the integral of x times du. So our du is dx over x. So dx over x. So now we will cancel out this 2x. So it will become x ln x minus the integral of dx. So our final answer is x ln x minus the integral of dx is x. So minus x plus c. So this is our final answer. So problem number 2, the integral of x sine x dx. So we will use this formula again. So uv minus the integral of v du. So it will become, so first let's find the u of this problem. So the u of this problem is x. This is our u, and our du is sine x dx. This is our dv. This is our dv. So our u is x. Our du is dx. Our dv is equals to sine x dx, and our v is equals to negative cosine x. The derivative of sine x is negative cosine x. So now we can solve this problem. So this will become our u is x. So negative x, because negative x, then v is negative cosine x. So cosine x minus the integral of the v. So integral of negative cosine x, then the du is dx. So dx, this will become negative x cosine x, then negative times negative is positive, so plus the integral of cosine dx. So our final answer is negative x cosine x plus the integral of cosine dx is sine x. So sine x plus c. So this is our final answer. So I will discuss now the integration by trigonometric substitutions. So the terms are the square root of a squared minus u squared. So the a squared is the constant and the u is expressed in terms of x. So this term, let u is equals to a sine theta. Then the second term is the square root of a squared plus u squared. Then let u is equals to a tangent theta. And the third term is the square root of u squared minus a squared. And let u is equals to a secant theta. So our first example for this topic is dx all the integral of dx all over x squared multiplied by square root of 4 minus x squared. So since the first is the a2, then it is minus sign. Then this is the longest part of the triangle, that is hypotenuse. So first we will draw our right triangle. So first we will draw our right triangle. Then then our square root of 4 minus x squared we will put here. So this is our square root of 4 minus x squared. Then this is our 2, our hypotenuse, and this is our x. Then this is our theta. So which means we will use sine theta, that equals to x over 2. So x is equals to 2 sine theta. So now we have to differentiate this. So dx is equals to 2 cosine theta d theta. Then we will substitute all of this. So this is equals to the integral of 2 cosine theta d theta all over 2 sine theta raised to 2 cosine multiply by 2 cosine theta. Then this will become 1 over 4, the integral of 1 over sine squared theta d theta. So this can be 1 over 4 cosecant squared theta d theta. So that is equals to 1/4 quantity of negative cotangent theta plus c. So this square root 4 minus x squared can be cosine theta. That is equals to 4 minus x squared all over 2. So cotangent theta is equals to adjacent over opposite. So adjacent over opposite is square root of 4 minus x squared all over x, and that is equals to negative square root of 4 minus x squared all over 4x plus c. So this is our final answer. So in our example number 2, we have the integral of dx all over the quantity of x squared plus 4 raised to 3 halves. So first, we have to notice that the exponent of the denominator is somehow a fraction form. So that is 3 over 2. We know that 3 over 2 can be expressed as 1 plus 1 half. So, ang pwede natin gawin dito is ilabas natin ang isang a squared plus 4 at itira natin ang x squared plus 4 raised to 1 half. So, that is the law of exponent na kapag same base ang minumultiply natin, we just need to add the exponent. So we have the integral of dx x squared plus 4 multiply by square root of x squared plus 4. So now, if this is plus sign, we know that this is hypotenuse. So we will draw our right triangle. So this is our hypotenuse. So So, square root of x squared plus 4. Then, this is our x, and this is our 2. We get this x because the square root of x squared is x, then the square root of 4 is 2. Then this is our theta. So this is, so in our term, the square root of a squared plus u squared, so the u is equals to a tangent theta. So our theta is tangent theta, and is equals to opposite over adjacent. So x, wait. So our x is equals to 2 tangent theta, and our dx is equals to 2 secant squared theta d theta. So that is cosine theta is equals to 2 all over square root of x squared plus 4. Then the square root of x squared plus 4 is equals to 2 all over cosine theta. So our x squared plus 4 is equals to 2 secant theta. So now we can solve the problem. We can solve this problem. So now we can solve the problem. So our dx is equals to 2 secant squared theta d theta. So our dx is 2 secant squared theta d theta all over 2 secant theta squared multiply by 2 secant theta. So cancel the secant theta squared and secant theta, and 2 secant and the 2. So that is equals to 1/4 the integral of cosine theta d theta is equals to 1/4 sine theta plus c. Then kunin natin ang sine theta. So sine theta is equals to x all over the square root of x squared plus 4. So our final answer is equals to x all over 4 square root of x squared plus 4 plus c. So this is our final answer. Now I will discuss the partial fraction. So I have two examples. The example number 1 is the integral of dx all over x squared minus 4. So first, let's set aside the dx and the integral sign. So we have 1 all over x squared minus 4. And then we decompose to partial fraction. That is simply equal to a all over x plus 2 plus b all over x minus 2. Then we will solve this problem of a and b. So 1 over x squared minus 4 is equals to wait. May nakalimutan ako. Our x squared minus 4 is equals to a plus 2 a minus 2. So now we can solve this. So we can solve our a and b. So this is equals to a x plus 2 x minus 2 all over x plus 2 plus b x plus 2 x minus 2 all over x minus 2. So this 1 all over x squared minus 4, this is equals to 1. Then we will cancel x plus 2 and x plus 2, x minus 2 and x minus 2. So so 1 is equals to a quantity of x minus 2 plus b the quantity of x plus 2. So 1 is equals to ax minus 2a plus bx plus 2b. So 1 is equals to ax plus bx plus 2b minus 2a. So let us now find the value of a and b. So 1 is equals to a. So 1 is equals to a plus b x plus 2b minus 2a. To find the value, we have two equations. So the first equation is a plus b is equals to 0. 2b minus 2a is equals to 1. Then a is equals to negative b. So that is 0. So 2b minus 2, the quantity of negative b is equals to 1. So our a is equals to negative 1/4. And our b will become, our 4b is equals to 1 and b is equals to 1/4. So our b is 1/4 and our a is negative 1/4. So we have the integral of negative 1/4. Negative 1/4 dx whole over x plus 2 plus the integral of 1/4 dx all over x minus 2. So now we can calculate that negative 1/4 dx all over x plus 2 plus 1/4 integral of dx all over x minus 2. So that is equals to negative 1/4. This will become the ln of x plus 2, then plus 1/4, and this will become ln of x minus 2 plus c. So this is our final answer. This is our final answer. So our example number 2 is the integral of x plus 1 all over x squared plus x cubed plus x squared minus 6x dx. So first, we will set aside the dx and the integral sign. So this will become x plus 1 all over x cubed plus x squared minus 6x. And then we will decompose to partial fraction. So this will become a all over x plus b x minus 3 plus c x plus 3. I know. X minus 2 pala. Sorry. So, we can solve the A and B. So, first, the x cubed plus x squared minus 6x is equals to x quantity of x squared plus x minus 6. So that is equals to x minus 2 and then x plus 3. So x plus 1 is equals to a times x minus 2 times x plus 3 all over x plus b x times x minus 2 times x plus 3 all over x minus 2 plus c x times x minus 2 times x plus 3 all over x plus 3. So now we can cancel the same of the denominator and numerator. So in A we can cancel x, in B x minus 2, and in C x plus 3. So now let us find the value of A, B, and C. So x plus 1 is equals to A x squared plus x minus 6 plus b x squared plus 3bx plus cx squared minus 2cx. Then we will distribute. So x plus 1 is equals to ax squared plus ax minus 6a plus bx squared plus 3bx plus cx squared minus 2cx. Now we were going to group. So x plus 1 is equals to ax squared plus bx squared plus cx squared plus ax plus 3bx minus 2cx minus 6a. So now we can factor out x plus 1 is equals to a plus b plus c times x squared plus a plus 3b minus 2c x minus 6a. So for our first equation, we have so for our first equation, we have a plus b plus c is equals to 0. Our second equation is a plus 3b minus 2c is equals to 1. And our third equation is negative 6a is equals to 1. So we can simply first get the constant. So a is equals to negative 1 over 6. This is our a. For b and c, we can use the a. So negative 1 over 6 plus b is equals to c, or is equals to negative c. So c will become c is equals to 1 over 6 minus b. So we have negative 1 over 6 plus 3b minus 2 quantity of 1 over 6 minus b and equals to 1. So negative 1 over 6 plus 3b minus 1 over 3 plus 2b is equals to 1. So 5b is equals to 1 plus 1 over 6 plus 1 over 3. Then 5b is equals to 1 plus 3 plus 6 all over 18. 5b and then 5b is equals to 1 plus 9 over 18. 5b so equals to 5b is equals to 1 plus 1 half, then equals to 5b is equals to 3 over 2, then b is equals to 3 over 2 over all over 5, that is equals to 3 over 2 times 1 over 5 is equals to 3 over 10. So our b is 3 over 10. So in letter C, to get C, we will put the C here so that we have space. So To get c, we can use c is equals to 1 over 6 minus b. So, c is equals to 1 over 6 minus the b, minus the b. 5 over 10. So, is equals to 10 minus 18 over 60. It is equals to negative 8 over 60. So, c is equals to negative 2 over 15. So, now we have, we can solve this problem. So, the integral of x plus 1 all over x cubed plus x squared minus 6x is equals to negative 1 over 6 dx all over x plus plus 3 over 10 plus 3 over 10 dx all over x minus 2 minus negative 2 over 15 dx over x plus 3. So it is equals to negative 1 over 6 the integral of dx over x plus 3 over 10 integral of dx over x minus 2 minus 2 over 15 the integral of dx all over x plus 3. So now we will integrate. So it will become negative 1 over 6 ln of x plus 3 over 10 ln of x minus 2 minus 2 over 15 ln of x plus 3 plus c. So this is our final answer for problem number 2. So the last topic is double and triple integral. So I have 2 examples for this topic. So example number 1, the integral from y equals to 1 to then integral of x is equals to 0 to 3 quantity of 1 plus 8 xy dx dy. So this is equals to the integral of 0 to 3 dx plus the integral of 0 to 3 from 0 to 3 8xy is equals to x from 0 to 3 plus 8x squared all over 2 y from 0 to 3. So this is equals to 3 plus 8 times 3 squared all over 2y. So this will become the integral of y equals to 1 integral from y equals to 1 to 2 3 plus 36y dy. So it is equals to 3y the integral from 1 to 2 plus 36 all over 2 y raised to 2, the integral from 1 to 2. So this will become 3 times 2 minus 3 times 1 plus 18 times 2 raised to 2 minus 18 times 1 raised to 2. So our final answer is 57. Our example number 2, we have the integral from 0 to pi over 2. The second integral from 0 to 1 y sine x dy dx. So this will become the integral from 0 to 1 y sine x dy is equals to y squared all over 2 sine x from 0 to 1. So this is equals to the integral of from 0 to square root of pi over 2 1/2 sine dx. So this is equals to 1/2 times the integral of sine is negative cosine x from 0 to pi over 2. So this will become square ang 1/2 negative cosine pi over 2 minus cosine 0. 0. This is 0 not theta. So if we calculate this, our final answer is 1/2. So I have one more example. So in example number 3, we have the integral of 0 to 2, then the integral from x squared to x, y squared x dy dx. So it is equals to the integral of 0 from 0 to 2 x, then integral of x squared to x, y squared dy dx is equals to the integral of 0 to 2 x y cubed over 3 from x squared to x dx. So this equals to the integral of 0 to 2 x x raised to 3 over 3 minus x squared raised to 3 over 3. So this will become the integral from 0 to 2 x raised to 4 all over 3 minus x raised to 7 all over 3 dx. So this is equals to x raised to 5 over 3.5 minus x raised to 8 all over 3.8 from 0 to 2. So that is equals to 2 raised to 5 all over 15 minus 2 raised to 8 all over 24. So if we calculate this, our final answer is negative 128 all over 15 or 8.5333. So these two are correct. So this is our final answer.